So students, today I will take this case of mutual inductance between the two circular loops which are at a certain distance on the same axis. One loop is larger in radius and size compared to second one. Second one, that radius will be small compared to the larger radius ring. तो इसका इंडक्टेंस कैसे मिलेगा म्यूचुअल इंडक्टेंस, दैट विल सी. इट इज द केस ऑफ म्यूचुअल इंडक्टेंस. Now, if I have to see this mutual inductance, in this case, there are two circular loops. One loop is here, say it is a larger one, and it has a radius r, and say carrying current I. Correct? Along the axis, say it is y axis, I have a second loop of smaller radius. Say it has the radius small r. They are placed on the same y axis, I can say, and center to center gap between them is y. I can say it is y, and this r is much less than capital R or even say y. इन दोनों से छोटा है. Correct? So what will happen? The current here, it is going I1 and this radius is r. I will try to find the flux. I will try to find the flux associated with the second one. Okay. What I will do? Magnetic field due to first, here what it will happen? So B1 due to first ring, this mu naught I r square over 2 times the value will be what? It is r square plus y square to the power 3 by 2. It is the expression of field due to any ring on the axis. So this value I am finding mu naught I r square 2 times r square plus y square to the power 3 by 2. This is already derived. Now I have to see the flux here. What I will do? Phi 2 flux will be the field due to first B1, but area of the second loop, that is pi r square. So this way, first of all, we get the value of flux. Then phi by I coefficient, that value will be the mutual inductance. So let us see. B1 is this mu naught I r square over 2 times r square plus y square to the power 3 by 2 into pi small r square. Correct? So this is the value of flux. Now I will say phi 2 upon I1. This will the value of mutual inductance between the two loops, phi 2 by I1. The flux associated with the second loop for the field lines. The field line due to this current flowing here, the field lines, they will go like this. They will be some field lines, they will pass through here. Correct? So these field lines, they will create a flux phi 2 by I1, that will be the mutual inductance. What value you can say? Mu naught into r square into pi over, this value is 2 times r square plus y square to the power 3 by 2. Now you see, this mutual inductance depends only on geometrical parameters. These are the only geometrical parameters: mu, r, capital R, small r, and distance. So all this, it is depending on geometrical parameters only. Correct? What next we can see? The flux. Vice versa also could have been correct. It means if the current is here, we have to find field here. But mathematically that is tough and we cannot see all the values and properly integrate. But this was the easier one. Any of the two, they will give the value of mutual inductance. Meaning that what I say, had you been able to phi 1 by I2, this will also give the mutual inductance. Correct? So both are correct. If I say here phi 2 by I1 and the value I write M21, here phi 1 by I2 M12, so both the magnitude are always same. The value of mutual inductance either M12 or M21, the values are always same. This we can see and prove also. Even not with the mathematics, experimental data will give the same result. Correct? It was for the two loops, meaning that if I am changing the current in the first loop, bigger circular loop, there will be induced current in the second one. So this phenomena is called mutual inductance. Other case also I will take for the same. Again the unit is Henry only. They also have the same unit as Henry, millihenry, something like that. Next, second case I see for the same mutual inductance. Second case, I am taking what? Combination of, it is a combination of two large cylinders, coaxial cylinders, combination of two large coaxial cylinders carrying the current in opposite direction. And how it is happening, just see. Say one of the cylinder is this. I will remove this one. Just hold on. So there is one of the cylinder this way, and it is carrying current, say, outward. Here the current is going outward, and see it has the radius small a. This has the radius small a, and coaxially there is a hollow cylinder, and this hollow cylinder carries the current inside. Both have the same magnitude, but this current is inside. Magnitude are same. Here the value is I, and this value of current is also I. Suppose it is like this. So these are the two large cylinders, and inner radius of the outer hollow shell, it is small b I say, and outer radius I can say it is small c. Now the thickness of this hollow cylinder is c minus b, and it is the solid cylinder. It has the radius a. Correct. Length are same. If I see the diagram, otherwise it is the cross sectional area. From the front it is showing. You can also take like this. One of them is the solid cylinder with radius a, and other one who is coaxial this way, and it has the radius value here. If you see, it has the radius value are b and c. Correct. These terms are there. So it is the similar pattern, and length is L. Length L is large enough. Now if I have to find the flux, so what I will do, again the self inductance for these two combinations we can see. If I see the self inductance and phi by I, this I will take the self inductance value. How do I get? See, this is the current carrying cylinder, large enough, carrying current I. I will try to find the magnetic field at a distance x, and this magnetic field doesn't remain constant at all the points. So I take this radius as x, and for this x radius there is some thickness also I will take. For this thickness of cylinder I can find out the flux. So first of all we will see the field. Field due to large cylinder, we know B value is mu naught over 2 pi I by x. This is the field value. Now this is the coaxial cylinder. This is, ये coaxial cylinder है जो इन दोनों के हिसाब से है, and it has the radius x. तो surface d phi flux, field into small area, so B is mu naught or 2 pi I by x. This is the field value. Now for this field value, if I have to go for the flux, so these field lines, if you see what will happen due to this current flow, if I have to see the field lines, how will they go? Say the current is coming outside, the field lines, they will have the pattern like this. The field lines, they will have the pattern like this surrounding them. So these are the field lines. Now these field lines, what will happen? They will fall on a rectangular plate of the same length L. I can take, there is a rectangular plate of the same length L. I can visualize. Just see, this is a rectangular plate of the same length L. I can see. So this is the rectangular plate existing between the two cylinders. It will exactly fit in. If these are the two coaxial cylinders, I will say there is this rectangular plate. This will exactly fit in between the two cylinders. It can go, and the width of this rectangular plate, what it will be? It will be B minus A. So I can take this thing to the flux value. What I will say, the small this rectangular plate, I will take one element of length L, and thickness dx. So this L thickness, this will create a area. Area will be L into dx. And this if I integrate, I will get the value of flux and all. Flux की value I will integrate from value A to B. From A to B, we can integrate and get the result. What is this flux phi? Just see. So mu naught over 2 pi, it is I into L integration of dx by x. This thing I can write, and it will integrate from A to B. So phi value, if you see here, it is mu naught over 2 pi I into L, and dx by x is ln x. Put the limit from A to B. So it will be log A minus log B, which is log A upon B. So this term, if I say phi by I, if I am doing inductance value will be mu naught over 2 pi into L into this ln value is B upon A. So this is the value of self inductance of these two arrangements. For these two arrangements of cylinders, the value of self inductance is this, and energy will be distributed in the space between two cylinders, hollow space between two cylinders, and this is the value of flux. This I have defined with the equation phi by I, that is self inductance, correct? But the same thing I can also derive by other method. Total energy, I can say here the total energy of the system will be half L I square. If I am knowing the inductance, I can say the total energy, associated magnetic energy of the system will be half Li square. L I have already found. It's a combination of two currents flowing in the opposite direction. It is similar to the capacitor plates. One current is coming out, ऐसे आगे आएगा, यहाँ पे enter कर गया. So in the space between the two infinite long cylinders, in the hollow space, magnetic energy will be stored, as similar to the parallel plate capacitor arrangement, like that. Correct? So this magnetic energy, I can easily find this value is half Li square. This term will happen, and the value I am getting mu naught L over 2 pi ln B by A. What I said, this value half Li square I can also get by second method. Second method is what? If I say this energy, it is also equal to B square by 2 mu naught into volume. This term is also defined for the energy associated with the cylinder, and we can relate the term. Let us see, can I apply this method for the same cylinders? If I take for the same cylinders, if I am doing, to say I will take a cylinder of radius x in the space between two, and B as a function of x. B as a function of x, if I say there, that will be B will be mu naught over 2 pi, it is I by x. This is the field at a distance x. What we know, for any cylinder gap between A to B, what you will find, this B is not constant. This B is varying inversely to the x. The B is varying. So for the volume, I will see this magnetic field lines, they will be associated with some cylinder of radius x, what I have taken. Again I will take some thickness dx, and it will include some volume. You can see this will include some, कुछ volume इसमें जरूर आएगा. इस volume को हम लोग देख सकते हैं कितना volume ये include हो गया. तो this volume dV is, I will say 2 pi x into L, 2 pi xl, and this is the curved surface area into dx. So this will give the volume. Now if I apply this term, I will say integration of du, that is the full energy, and B square if I do, so B square, you see what the value is, mu naught square I square over 4 pi square x square into this, it is 2 pi x into dx, and length L is obviously given. If I multiply this term, energy density into the small volume and integrate, from A to B, we will get some result. What the value it is? U is equal to, just see what the term I will get. Just see, यहाँ पे देखिएगा, it is L into I square into mu naught square upon this value. If I say it is 2 pi, and this term, if you see one of the, this is the x square I was getting, one of the x got cancelled, so dx by x, integration of dx by x, this term I will get, correct. I will again integrate it from A to B. Rest of the terms they are coming here. For the whole energy, integration mu naught square, and this whole value I square L by 2 pi dx by x is ln x. So this value further I will get L I square mu naught square over 2 pi ln B by A, ln B by A, this result will have, correct. This is the energy stored. And if I compare this result with half L I square, na, if I relate the term, what I will get? Just see here, mu naught by 4 pi, a B value it was mentioned, and B square by 2 mu naught, na. So this value, if you see, it was B square. First of all, B is this, the B square by 2 mu naught. Also the value I will put 2 times mu naught, correct. If I am putting here 2 mu naught, 2 into mu naught, this is also there, correct. So this value if I put, so this term I was getting 2 mu naught. If I am dividing the whole expression, initial what it was by 2 mu naught, what I will get? It is mu naught L I square by 4 pi, 2 pi into 2, it is 4 pi I square, and the term is ln B by A. Further what I will get? Just see, this terms mu naught L over 4 pi ln B by A into I square. If I compare with the equation energy U is equal to half L I square, what I will get? Coefficient of I square term, this coefficient of I square if I get, correct. What I will see? Coefficient of I square is this is for inductance half I square. Value will be half L I square if I compare L Q value mu naught L by 2 pi ln B by A. The same thing we have got from the other expression, L is equal to phi by I. L is equal to phi by I and this. So these are the two methods for defining the inductance. It is either phi by I, L key value, there I said L key value, it is phi by I, or I can say U is equal to half L I square. So both the methods they define the value of inductance. That way it is, and it behaves like quite similar to the parallel plate capacitor, like that. Thank you.